Hey, welcome back to another episode of Detection at Scale. Today I'm here with Chris Hodson, who is the CISO at Contentful. Prior to Contentful, he was at Zscaler and Tanium and a bunch of other great places. And he also has a book on cyber risk management. Chris, welcome to the show.
Hey, Jack. Good to be here.
So before we hit record, I was thinking about this question of what's your hottest security take?
Highest security take. I'm not sure if this is particularly hot or potentially unpopular, but there's lots of talk in our industry around the technical needs of a CISO, and does the CISO need to be technical? And just from my experience, I've kind of found that the best boardroom CISOs, the ones who are able to articulate risk in a way that resonates with non-security folk, actually have kind of a fairly detailed understanding of the kind of the esoteric aspects of that, be it an incident, be it like an architectural challenge. So when I hear people say, and sometimes I think it's for mouse clicks and for conference talks, but I hear them say CISOs don't need to be technical. I think I did write this in the book or somewhere. I don't know many CFOs who say they don't know about finance. So apologies, non-technical CISOs, and I don't want lots of comments on your iTunes, but I don't know. Off the top of my head, that would be one I would say. Yeah.
Where do you think that dichotomy comes from?
I think it comes from kind of roles prior to being a CISO, right? And, I also want to say that I do know some non-technical CISOs who have great teams, I should say, who are technical and, kind of bridge some of those gaps or cracks maybe. But, if you think about the role of the security function, right, you kind of have two paths that I've seen them. You have kind of the CISO who's come from a very technical background, maybe systems engineering, maybe they've been a security architect and kind of cut their cloth that way or cut their teeth rather, and then kind of moved into the security exec role. I see other CISOs generally happens in larger organizations who, the individual has a very strong kind of cross-functional kind of business reputation. They've executed well in maybe finance or in the people team or in legal quite a lot of the time. They then move into security because they kind of have that gravitas within the organization that helps them succeed there. So like I said, I've seen some great CISOs who've done that, but most of them have gone through the process of learning the technical side of it.
I assume on the spectrum, you're on the technical side, just given your background. So how did you start sort of learning the skills that, would better enable you as a technical CISO?
I think what helped me was I spent a long time as a consultant or a contractor. So when you talk about cross-functional business engagement, when you talk about kind of skills for particular industry verticals, doing that and working for lots of different organizations, I think allowed me to deal with lots of different types of people in specific roles. I was in financial services during the time when every job description said must have 5 years of experience in financial services. And, you're getting into that and you think, why is that? And, at the time, I think FS was the first place that really started to care about InfoSec and cyber. And, it was almost that vicious circle of, well, how do I get the experience if I can't? And, I was lucky enough to start with a few kind of retail banks in the UK as a security architect. Woefully underqualified, like genuinely like had good security skills as like an engineer, but getting that more kind of macro or abstracted high level view of the world was something I learned a lot of on the job. But in doing that, I think that kind of gave me the grounding to kind of start to look at leading security functions. And I took that kind of transition from security architect, senior security architect to kind of security management and then running the show in, so to speak.
And that's a good segue into where we are today. So we've come a long way from protecting the more monolithic infrastructures that have servers that you physically rack, and now we're cloud-based, AWS, GCP, Azure, like all of that. How do you think the mentality around detection has shifted from the days that you were just starting in financial services to now?
I'm going to try and answer this without using the phrase cattle versus pets, but I think certainly when you were back in the old days or racking and stacking servers, data centers, like all your security infrastructure was also kind of in those data centers and you had kind of full control of kind of dedicated environments. I see now with kind of cloud, SaaS-based kind of IaaS, PaaS, containers, EKS, whatever it is, there's just so much telemetry and there just aren't the opportunities for just kind of dumping agents everywhere. I think that's the biggest change. You had, racked and stacked servers, and everyone was fine with kind of deploying all these things that ran on them because, hey, what's a few CPU cycles? What's a bit of memory on a Windows, whatever it is, 2008 server? You look now, I mean, take my current environment, this is public knowledge. Like, we are kind of a headless API content-based platform, and we run on microservices. You look at detection and response, you can't go dropping agents on very small footprint containers that are spun up and orchestrated by a case. So, looking at other ways of doing that, looking at passive ways of gathering as much information as possible. And I think also working a lot more closely with kind of the DevOps teams, like understanding how things are supposed to be built, understanding kind of the technical architecture to then build detections for kind of very cloud native challenges that possibly we didn't have in our kind of bare metal, in our physical world, in our data centers. I don't know if that's a good answer or not, but that's how kind of I look at it. Security being much closer to kind of the engineering and development teams and understanding about not only the infrastructure, but also kind of application logic as well when we're building out detections.
So how does the team get smart about what to detect?
Threat modeling. I think threat modeling, and that may be a trite answer. You may have heard that like kind of 50 or 60 times, but, actually understanding from an internal perspective how things are supposed to work, understanding data flows, understanding all the intermediary steps on a process, I think kind of helps us. Staying abreast of what's going on in the industry, I think as well, via threat intelligence, industry forums and groups. We leverage a managed service for our 24/7 SecOps, and we have kind of detections that we consume via them. Again, we are an organization, the entire organization, I don't just mean security, of roughly 1,000 people. I don't have the resources to have 20 people who are looking at SecOps and then 5 others doing detections engineering. So, taking intel, taking detections from our MSSP, and also leveraging kind of the threat intel from, other security solutions that we have, be them endpoint AV, be them kind of the email gateways that we deploy. So trying to get as broad a detections picture as possible, like from identity all the way through to what we're provisioning in, for example, Kubernetes, I think.
An area I've always found really interesting is application logging. So you talked about Kubernetes a few times. You talked about the security teams sitting with the engineers. How do you work well together with application developers to get important data that's useful for security? Because oftentimes app logs are just like total garbage. How do we make that not the case?
Getting involved kind of really early in the life cycle, understanding kind of the requirements of kind of the development and the product teams, and building out that kind of very early, even if it's just like a product requirements document. So you understand very early on, we're trying to do this thing. There's a discovery phase of an application, and getting to know it as it's built. I know that sounds very kind of fundamental or macro, but if you have a logic and you have an understanding of what's being built, once it has been built, it's then much easier to be able to establish what's supposed to be happening and what isn't. There's no way that you can consume, to your point, all application logs and build kind of signal from noise necessarily. But if you understand the sensitive data assets that an application is storing or processing, if you understand particular user accounts and particular repos that are of concern, kind of having detections that fire on those rather than just trying to look for a needle in a haystack. I haven't got the silver bullet. Like, I don't know the way. I've been in lots of organizations who have had this problem of building web apps, then building applications, and then, just having a deluge of data. But, just working very closely with devs and regularly, and understanding a little bit more about how things are constructed, I think.
So you said you would pick out specific services, certain repos, right? I assume in microservice architectures, you have like separate GitHub repos for what we're using for version control. That makes a lot of sense. So I think that's actually a good lesson to take away, right? It's like prioritize the services that are the most sensitive. So things that are touching customer data, things that are touching anything sensitive, like pay attention to those the most. The thing I'm always curious about is like, what signal do you care about when it comes to the application doing things?
I was going to say things that it's not supposed to. That's incredibly, incredibly obvious. But, if you're building out those detections of misuse cases, so again, giving away secret source or anything, kind of looking at kind of things that we know applications are supposed to do, and then kind of building out almost like capture the flag style scenarios of things that aren't supposed to happen from a front end perspective, and then building detections on those from the back end. So when we're looking at security assurance, that's certainly something that we consider, like misuse cases, like what isn't supposed to happen with this application? Like how could someone steal a session token in transit? Like if someone gets access to this database, then what would be the worst thing they could do? Could they drop it completely? Could they exfil data? Trying to build out detections that way and make them contextual to the application, because you know, something that works for one piece of your environment wouldn't necessarily work for another, I think.
Yeah, that's a good point around understanding those access points. Like if an attacker is able to, through the web application, access a proxy to something else, like do we have eyes on that? I think that's an important piece.
Well, I think that's where, so in our organization, business resilience sits under kind of the security organization as well. So something we try and do is look at things from and you may have heard this before, but start with kind of your business processes. And then from your business, so this has nothing to do with applications or technology, but start from your business processes. Finance wants to do a thing. Look at the applications that support that process. Then look at the infrastructure that supports that application. And then look at the data flows. So that's kind of a program of work we're doing at the moment. So when someone says this information here is confidential, quote unquote, great. Okay. You know, it sits in that file store, but where is it actually being transferred from and to? How are things getting deleted? Who has access to it? How are you doing RBAC? And having that kind of end-to-end view allows you to build a much more kind of, I suppose, holistic threat model rather than just, I mean, that's one of my pet peeves. You asked me earlier, you know, hot take, thought of another one now is, you know, like pen testing an individual application, running a ton of automated scans and saying, you know, here's a ton of vulnerabilities, as opposed to saying, I want to see if you can access those particular credentials or that SSH key in that environment. Do you know what I mean? So yeah, we're building out a much, I don't want to say holistic again, but, you know, a much broader view of what's critical and what's important to our organization rather than just picking individual systems on a chain, if that makes sense.
Yeah, I like your point too around it's not just about the list of vulnerabilities, because you could have millions of those, right? It could be like, oh, you're on an outdated OS. It's like, okay, who cares? Like, is it actually 100%. A problem? Or is it just like some information low severity finding that doesn't really become actionable? That's a good take.
Completely. And another challenge with that approach is, even if you understand the severity and the impact, it's still not a risk. You know, it's something that's just point in time. It's kind of abstract of any business impact. So getting anyone outside of the security function to remediate or change their approach to remove it, it's very difficult, I think, in that way. So
yeah, risk is a really interesting idea, even in detection, because I think we're shifting from this world of we got one atomic alert to now we're looking at things in aggregate. How do you think about risk when it comes to observing your environment?
Again, I think it's having the right visibility of essentially everything that matters. Now, that might sound like a political response to that, but, you know, if you don't have ingestion of the right telemetry into your SIEM, into your MSSP solution to be able to respond to things that matter, then, you know, you're going to have a myopic view of potential incidents, right? So I see a lot of companies fail in that regard of, hey, you know, they might have their email and collaboration tool logs being sent to a SIEM, but for some reason they don't have their Okta logs, for example, or they're not having their kind of AV logs. So being able to build out a picture of kind of, I suppose, I don't want to say kill chain today at all, Jack, but, you know, an end-to-end incident is critically important. And that's something that we've spent a lot of time doing, is thinking, right, okay, so we're building out a number of tools at the moment internally, both on our corporate side and on our kind of production side, and making sure that all of those tools can send relevant telemetry to a centralized source and allow us to build detections, or to have our third parties build detections is important. So when you think about risk, I think it's about identifying the systems that can help us in the event of an incident. Now, I wouldn't say that that's not how I would explain risk to my audit committee, but that's how I would explain risk from a detections here. We're not talking about kind of SIMs and what we're doing with Splunk. But yeah, I think that's the critically important thing. If it gives us visibility that allows us to respond to something, then from a risk perspective, that's what we want to make sure that we have the signal from, to be perfectly honest.
And you mentioned building tools. Can you briefly describe, I mean, you don't have to give me anything specific, but I'm curious, like, I don't know, it's often not recommended to build things, but it's like, there's obviously good reasons when things are very custom. So I'm always curious, like, what are you building? Like, can you describe what it is? And if
Oh,
it's
no,
a reaction to a bad commercial tool versus like being good custom, you know?
I was going to say that would be great content for you, Jack. No, we're not. We have a program of work where we're building a security program. Like, I'll be perfectly honest with you, there is nothing that I can possibly, a few kind of Python automation scripts, but there's nothing whereby we have said, right, an off the shelf product or service isn't fit for purpose for our organization. So, I'm not backtracking. We genuinely haven't gone, right, okay, I don't know, this whatever EDR tool doesn't work for us. So, hey, we're going to build it. No, we haven't done that. We're certainly SaaS first. I will say, we want to be in a position where from a security tooling, we are not building our own kind of infrastructure tools or security tools and owning them. So if we can go direct to internet, then that's the approach that we would take. And most CISOs I speak with are kind of that way now, build a SaaS security standard. So say, hey, it must integrate with MFA. Hey, we must be able to send the logs to somewhere from for detection and response. But we're not building very much from a tooling perspective anyway.
I actually really love that point you just said. So the tools that we're integrating with now as security teams have to be this SaaS minded. They have to have MFA. They have to send their logs somewhere. They probably also need to have a few other things like SSO support, et cetera, et cetera.
Yeah, definitely.
Do you see that as fairly ubiquitous today, or do you see it as like we still need to do better as vendors?
I think it's fair. I think it's ubiquitous. I think that's the case. I think the kind of industry, I'm going to say paradigm change later, have kind of driven everyone to this kind of zero trust model, this like eradication of a local area network, where you mentioned it earlier. Hey, we're not in data centers anymore. We're not racking and stacking stuff. So if we can go directly out to the internet, gives us a ton more flexibility in kind of where people work, how they work, devices that they use, removal of VPNs in, 90% of cases. So it's fairly ubiquitous. The biggest challenge that comes from it, obviously, is application sprawl. Like if someone doesn't need to go and talk to security or IT and can just go, hey, we're just going to get a credit card out and buy access to an application. It's difficult to kind of know about that. But, from our side of things, I go through a fairly kind of rigorous process of onboarding vendors. And the few that I mentioned there were just I suppose a cross section of the questions that we ask and the requirements we have for tooling.
You said that your team is building stuff internally. So can I imply that they're engineers? Or like, how do you describe the breakdown of your team?
Yeah, no, good question. So we have a security team that spans all of the organization. So we have dedicated product resources, which I don't think's uncommon in a technology organization. So working very closely with our product teams. We align like with the Kubernetes 4Cs. I think that's something that resonates quite well with people inside and outside of security, of saying, looking after your kind of code, your containers, your clusters, and your cloud. And that's a dedicated team in my organization who do that. And that's great. And then we have a broader kind of wider enterprise security team who look after the services that everyone in the organization uses. So identity, security operations, vuln management, they all fall under another team. But, if you're, and I think this is true, I'd love your view, actually, I'll interview your view on this, but, tech companies are moving to kind of DevOps models, or have had DevOps models for a number of years. Security has to move with the times and be embedded with those teams. So if your engineering team are writing everything as infrastructure as code, security needs to be doing the same. We need to be conversant in the tools they're using. We need to understand Terraform. We need to be able to write security templates to be able to qualify if things have vulnerabilities and misconfigurations in them. All of that stuff, generally engineers. So there'll be occasions where we'll have analysts from a SecOps perspective, but the bulk of people who can add value at the moment sit in the kind of more of a security engineering space. Something I would say I'm seeing more of, and something that when I look for candidates, we certainly find very attractive, is having that blend. So I think maybe 5 years ago, you would look for either an AppSec engineer or an infrastructure engineer, in the sense of you'd have those more kind of end-tiered architectures, right? You could have somebody looking at app and then another team looking at kind of the infrastructure. And with all things microservices, I feel was kind of a convergence of those things. So, I suppose that brings you to that true sort of DevSecOps, doesn't it? People who have an understanding of how to build the infrastructure side, or now largely it is Terraform or whatever AWS is. Was it CloudFormation?
I like the Kubernetes 4Cs. I've actually never heard of that because I never
Uh,
worked intimately with Kubernetes, but
yeah, I can't necessarily I don't know if security engineering manager is going to hear this, but yeah, we jammed on the best way to explain what we did. Because I think security is, like I said earlier, it's esoteric, it's confusing to people. Hey, you're a security engineer, but you're not working in the product space, or hey, you're an architect. So by defining the 4Cs, certainly when you look at teams who work in technology, everyone understands code, like code in its many different forms. If it's infrastructure or app, still code. Clusters, maybe everyone doesn't understand clusters, but if you work in a microservices Kubernetes environment, you do. And then containers and cloud are fairly ubiquitous and synonymous with microservices. So
yeah.
that's not a takeaway for everyone today. Yeah.
I love the point about security becoming enabling in a cross-functional sense. And we see this actually in product teams too. Because now, even at Panther, like we have teams that are EPD teams. So it's engineering and product. So you have like front end, back end, you have engineering managers, PMs, designers, all sort of working in one unit. And it's interesting to think about that same cross-functional team as a security, with a security mindset of security engineers sit with the DevOps engineers to make sure that we're writing Terraform in a way that's secure. Or if we identify a certain standard that we want to hold, we're working with the teams to educate them on that. So I think that's a really cool evolution of where we are today.
Well, thank you. No one's ever complete, I don't think. And there's iterations as to how you do that. I don't know, advocacy or training or kind of close way of working. But yeah, we're making some real progress there. So when you look at kind of vulnerabilities, when you look at, everyone uses Jira, when you look at Jira cards, we're really trying to make sure now that when we put something in a queue, well, we don't, we actually don't do that. So I was going to say when we put something in an engineering queue, but now what we're trying to do is work with kind of more of the engineers, more developers to say, this is something that we have found. This is a defect. This is a vulnerability and misconfiguration. How should we contextualize this so that it gets the necessary prioritization in your queues? Because I see too many, I speak with lots of friends of mine who are CISOs. They all have the same tools. They all pump out lots of traffic light style, red, amber, greens, or CVE scores, or whatever it is. But they don't mean a lot to kind of development teams who have, their own things to do. They have their own OKRs, they have their own deadlines, they have their own sprints that often have, very little to do with security. So getting things, explained in a way that resonates, however trite that sounds again, is, something we've been spending a ton of time on.
Yeah, it's so non-trivial as well. It's just security is a very different mindset. It's like DevOps. Even DevOps is a very different mindset from just core software engineering. So it is very helpful to have those trusted partners. And I'm thinking about right now, like how far the way do tools get us in that versus needing a human always? And I think you could apply that question to like detection and AppSec and cloud security and things like that. Like, how do you see that balance as like tools are getting us X to the percent of the way there versus like the humans take us to the last like mile or whatever?
I think they've come a long way. I'm sure you knew I was going to say that, but I think, getting environmental context, getting prioritization of the stuff that a company should focus on, because it isn't always the highest CBSS score. I'm sure I'm preaching to the converted on that, but, tools have come a long way in terms of saying, hey, this particular endpoint over here, it's not rootless and it's exposed to the internet and it's, looking after payment information. Consequently, even kind of medium level vulnerabilities or misconfigurations here are more important and should be prioritized over, let's say, I don't know, CVSS 9.1 over here on the canteen restaurant menu, So I think tools are helping a lot with that. Where tools, I don't think necessarily go everywhere, or I think you said the last mile. I think the last mile, or probably the last kind of 5 kilometers from an engineer's perspective, is much more around just looking at how you can group multiple alerts or multiple incidents or multiple vulnerabilities into kind of categories rather than just these individual things that fire. And that for me is where you can work with engineers and developers on fixing things at source, looking at the cause rather than the symptom. And I won't go into specific tool names here, but lots of tools. I've seen tools that will give you 200 instances of a misconfiguration in a container, for example. And I've seen security teams run off and go and try and fix 200 instances of this problem and raise lots of tickets of Eng, when in fact you could change a line of a configuration of, Docker file, and it would fix it once, then have that rebuilt. So tools, I don't think, get you all the way with that level of kind of pragmatism. And yeah, let's just call it that. Maybe I'm wrong. Maybe there are tools out there that literally make most kind of engineers and analysts obsolete, but I haven't found one yet.
Yeah, there's always an opportunity, I think, for tools to get more contextual.
Yeah.
Or to enable the team to make it easily contextual. And what I mean by that is, like, if you think of detection as this like very broad funnel, so you have this superset of all possible things that could go wrong. Like if you look at MITRE ATT&CK, right? Like the entire matrix. And then it gets a little bit more specific. You're like, okay, well, in my environment, we're just using AWS, let's say, or we're just using GCP. It's okay. Now it shrinks a little. And then it's like, and we're actually only using Kubernetes, or we're only using serverless or whatever. And then it shrinks a little bit more. That sort of adaptability should definitely be easy and trivial in tools. So then we're really focusing on really the only like 10% of that last chunk where a human actually needs to get involved. And I think that's probably how we evolve as a security community, and not needing to always rely on like external services like MSSPs. And because I think that's really just like a staffing thing, but also like an enablement thing based on the tools. So I think we can get better about being just customized and making it tailored but easy.
Yeah. I think that's fair. I think certainly if you look at like CIS benchmarks and the like, for example, NIST standards, knowing which parts of those are most relevant, that goes to detection as well as kind of like configuration management, right? Like understanding which of those areas are most important for your app and which don't apply. Yeah, going through that exercise. I think that's why a lot of companies don't take these kind of standards off the shelf and do kind of tailor and curate and add bits of one to another, because they don't always apply without doing so.
Awesome. Chris, this has been really fun. I want to wrap up with one final question, and I'd just like to end with takeaways that people can sort of walk away with and hopefully bring it back to their security team and sort of continue pushing forward in the right direction. So what are 3 pieces of advice that you would give to detection teams who are living in this cloud-based world?
I would say, firstly, we touched on visibility, but ensuring that you are able to have telemetry from the various stages of an attack path. So think about the different solutions in your environment that allow you to do that. If you use a SIEM, or you're using a SIEM and an MSSP, are you in a position to be able to take something from kind of the left-hand side of an attack path to the right-hand side? So do you have identity? Do you have infrastructure logs? Do you have application logs? Do you have the logs from your AV and your EDR solution? And if you do you actually know what those pieces of telemetry, the information from those that will allow you to effectively kind of triage and respond to an incident? So think about that. I suppose stay curious as well. And we talked about kind of my career path before, but technology changes so quickly. I got into security in the world of like Windows 2000 and MCSEs and whatnot. And you think about the skills that I learned there, and are they relevant today? Largely not, right? So, I would say for anyone in the industry that, to stay on top of kind of technology kind of changes and paradigm shifts. And I suppose thirdly, and we touched on this as well, but, keep a close working relationship with whatever's kind of producing your product. So in my world, it's engineering and product teams. In an automotive organization, it would be manufacturing of cars and the systems that support that. But when you start to think about the why of a cyber intrusion, invariably people are looking for kind of crown jewels assets, things that they can sell, etc. So knowing what those are in your business, I think sometimes we get a little bit too self-assured on that. We think, right, we know what's important. It's AD databases, it's SSH keys over here, when in fact, a lot of the time there's intellectual property that you need to build detections around. So I don't know if that's 3. I think that was 3, but they would kind of be a few things. There you go. They would kind of be a few things that I would focus on, definitely.
Awesome, Chris. This has been super fun and honestly very, very insightful. I think the things we talked about today were really useful, and I hope people listening in got a lot of value from that and learned a little bit more about how you're thinking about detection in such a cloud native first environment like Contentful.
Thanks very much, Jack.